Hi everybody. In this video we are going to see the basic mathematical operations in matrices. Okay. So first let us see the addition and subtraction of matrices. This addition or subtraction of matrices is only possible, please consider this, only possible if they are of the same order, that means same dimensions. If both matrix have same dimensions, then only we can add or subtract them. If they are of different orders, it's not possible. Addition or subtraction of matrices is not at all possible. For example, here a matrix is given as A is equal to 1, 3, 2, 4, 5, 9, 6, 0. And I'd like to write here what is the order of this matrix. I mean dimensions. We have 2 rows and 4 columns, 1, 2, and the number of columns is 1, 2, 3, 4. So we can write it as 2 by 4 matrix, isn't it? So this A is 2 by 4, and coming to the matrix B, we have 2, 1, 0, 3, 8, 5. Here also we have 2 rows and 4 columns, so it is 2 by 4 matrix. So the dimensions are same, so we can add or subtract these two matrices. So how we are going to add these two matrices? Very simple. We are just adding the corresponding elements of them. That means if we are adding A and B, the first row first element of A matrix must be added to the first row first element of the B matrix. Simple. So the corresponding elements of the particular matrix must be added. So this A11 of A matrix A must be added to A11 of the matrix B. So 1 plus 2. Similarly, the second element of first row in A and the second element of first row in B must be added. So 3 plus 1, 2 plus 0, 4 plus 3. Got it? Simple. So similarly, the first row is over, and coming to the second row, the second row, first element of the second row must be added to the first element of the second row in B. So 5 plus 8, 9 plus 5, 6 plus 6, 0 plus 4. So if we add these two, we will get the addition of two matrices A plus B. So the A plus B will be 3, 4, 2 plus 0, 2, 4 plus 3, 7, and 5 plus 8 is 13. Coming to the second row, 9 plus 5 is 14, 6 plus 6 is 12, and then 0 plus 4 is 4. So the addition, and I repeat, the addition or subtraction of matrices is only possible if they are of the same order. So coming to the subtraction part, the same procedure is followed. Instead of adding or subtracting the corresponding elements of the two matrices. So A11 must be subtracted from, that is A11 minus A11 of matrix A minus A11 of matrix B. That's all. So 1 minus 2, 1 minus 1, 1 minus 2, 3 minus 1, 2 minus 0, 4 minus 3. This, third, this. That's all. Simple. Similarly, for second row also, 5 minus 8, okay, 9 minus 5, 6 minus 6, 0 minus 4. So while subtracting the two numbers, you have to keep it in mind the importance of the negative symbol. So 1 minus 2, negative 1, 3 minus 1 is 2, 2 minus 0 is 2, 4 minus 3 is 1, 5 minus 8 is negative 3, 9 minus 5 is 4, 6 minus 6 is 0, and then 0 minus 4 is minus 4. So addition and subtraction is thus you have to do. Okay. Then coming to the next topic, multiplication of a matrix by a scalar quantity. Suppose if A is a matrix and K is any scalar quantity, then the resulting matrix is K times A. So Ka is, then the resulting matrix is K times A for the multiplication of matrix by scalar. For example, if A is given as 1, 2, 5, 2, 4, 9, 0, 1, 6. Okay, and let me write it here. This matrix is of the dimension 3 by 3. This is a square matrix of order 3. So 5 times A, 5 is any scalar quantity. 5 times A is given as 5 times into the matrix A. That means the elements in the matrix, each and every element in the matrix A must be multiplied by the scalar quantity. Okay, so each and every element should be multiplied by 5. So that is the resulting matrix. So 5 times 1, 5, 5 times 2, 10, 5 times 5 is 25, 5 times 2 is again 10, 5 times 4 is 20, 5 times 9 is 45, and 5 times 0 is 0, 5 times 1 is 5, 5 times 6 is 30. So this is how the scalar quantity should be multiplied. Each and every element in the matrix must be multiplied by the particular scalar quantity. If it is minus 2 times, for example, a matrix 2 cross 2 matrix 1, 2, 6, negative 2, for example. So you have to multiply each and every element in this matrix by minus 2. So what you will get, minus 2 times 1 is minus 2, minus 2 times 2 is minus 4, minus 2 times 6 is minus 12, and then minus 2 times minus 2 is positive 4. 2 minus 2 into minus 2 plus 4. So this is the resulting matrix. Okay. Then now coming to the matrix multiplication, that means when two or more matrices, we have to find the product of two matrices, not by scalar quantity. A matrix is multiplied by another matrix. So multiplication of two matrices is possible only if the number of columns in the first matrix, okay, equals the number of rows in the second matrix. This is the condition for matrix multiplication. Okay, for matrix addition subtraction, it should be of the same order, dimensions, but here the number of columns in A must coincide with the number of columns in B. So M by N, A matrix, order of A matrix, and order of B matrix or dimensions of B matrix is M by N by P. If you multiply these two, okay, then the N, this should coincide. Number of columns in first matrix should coincide with the number of rows in second matrix, and the resulting product will be of the order M cross P. Understand? So for example, here it need not be of the same order. Okay, same order also we can multiply. Then provided this condition, for example, in this matrix is of order 2 by 3, isn't it? 2 rows and 3 columns we have. And for matrix B, it is of the order 3 by 3. Okay, so if you multiply these two, this should coincide. So this, yeah, here number of column is 3, here number of rows. So it will merge and you will get the final answer 2 by 3. Okay, so the product of AB will be 2 by 3. That's all. So how you are going to multiply the two matrix? You have to take the first row and first column, and then you have to find the product of the corresponding elements. Product of the corresponding elements means first into first, second into second, third into third. That's all. So 1 times 1 into 2. Okay, first row first element, here first column first element, plus second element, here second element, 3 times -1, plus last element 2 times 1. So the combination of these products, I mean the sum of these products will give the final answer. So 1 times 2, okay, this first row first column, you take this first column, take this first row, okay, find the product of corresponding elements. Corresponding elements means first number into first number, plus second number into second number, plus third number into third number. That's all, simple. Okay, so 2 minus 3 plus 2. Similarly, first row and second column. Now this first one is finished. Now we are going to the second column. Okay, so first into first, 1 times 3 is 3. So directly I have written the answer here. 1 times 3 is 3, plus 3 times 6 is 18, plus 2 times 1 is 2. First into first, second into second, third into third. Finished. Next, coming to the third column. That means you are going to the next third column. Again, first into first, 1 times 1, 3 times 2, 2 times 3. Finished. So first row first column, first row second column, first row third column, sum of the product of the corresponding terms. Finished. Similarly, second row. Now you are coming to the second row. The same method is followed. Second row first column. So 5 times 2, 10. 1 times -1, -1. 4 times 4. Again, second row second column. 5 times 3 is 15. 1 times 6 is 6. 4 times 1 is 4. Then second row third column. 1 times 5 is 5. 1 times 2 is 2. 4 times 3 is 12. Now you just add all these terms and write the matrix AB. So 2 minus 3 is -1, or you can add like this. 2 plus 2 is 4. 4 minus 3 is 1. Then 18 plus 2 is 20. 20 plus 3 is 23. 6 plus 6 12. 12 plus 1 13. Coming to the second row, 10 minus 1 is 9. 9 plus 4 is 13. And then 15 plus 6 is 21. 21 plus 4 is 25. 5 plus 2 7. 7 plus 12 19. So the resulting AB is of the order. Now we can write this is of the order 2 by 3. Yes, we got it. Okay, so the condition is which two matrices you are going to multiply. The order you have to take it into account. The number of columns in the first matrix should coincide with the number of rows in the second matrix. That's all. Okay. And one more point I'd like to tell you now. In general, that means in general, usually AB is not equal to BA. We call it as, if AB is equal to BA, we call it as commutative property, isn't it? So matrix multiplication is not commutative. Ordinary multiplication, it's always commutative. As 2 times 3 is 3 times 2 is same. But here matrix multiplication is not commutative in general. But there is a one specific case. Okay, if we have to see about the inverses in later videos. If they are inverses to each other, if the matrices are inverses to each other, that means A inverse equal to B or B inverse equal to A, then the product will be same. I mean AB will be equal to BA. In general, matrix multiplication is not commutative. Okay, the property AB equal to BA represents the property commutative. So matrix multiplication is commutative If it is commutative means then they will be inverses to each other, that is the condition here. But if A inverse equal to B, inverse of A is equal to B, then they will be equal, and they will be equal to identity matrix. You know what is an identity matrix? The principal diagonal elements will be 1 and the other elements will be 0. So these are the basic mathematical operations of matrices. Okay, thank you for watching.